Hi everybody! The purpose of this video is to go over the first part of section 2.3, and we are going to be talking about solving linear equations of the form x plus b equals c. So let's get to it. What are we going to do in this video? Well, we're going to talk about what a linear equation actually is, and then yes, we're going to talk about linear equations of this particular form, namely where we take our variable x, we add something to it, which will produce another number c, and we want to figure out what value of x will actually make that happen. And we are going to look at, one, determining if a number is indeed a solution to this equation, how to actually find the number that is a solution to this equation, and also how to simplify various equations so that they reduce into this form, and then once again how to solve it. So what do we call a linear equation? Well, this is a linear equation. We always start off with our variable, which is x. We might multiply it by a coefficient, which we will call a, and that's nothing more than a number. We might take that product and add another number to that, which in this case we call b, and that'll be equal to c. And our objective is to find that value of x, which would make this statement true. Once again, a is a real value constant. However, a is never 0, and b and c are also real value constants. And why can a not be 0? Well, if a is equal to 0, we have b is equal to c, which basically means that, well, yeah, you guessed it, b is equal to c, and that's pretty much all that we can do. Not much fun in there, at least not from my humble opinion. Another thing about the linear equation is that it is considered a first-degree equation in x. And why do we say it is a first-degree equation in x? Because the term of highest degree, in other words, the term which has the independent variable in it raised to a certain power, and that's power 1, determines the degree of an equation. Now this term right here, since it has an x raised to the first power, which basically was what we're implying here, is a term of degree 1. This one, since there is no variable, is a term of degree 0. And this right here is also a term of degree 0, since they're the exact same thing anyways. So since this expression since this equation has 3 terms in it, and the term of highest degree is 1, we say that this is a first degree equation. And since this is a first degree equation, what does this tell you? It could tell you a lot of things, but the primary point that I'm getting at here is that since this is a first degree equation, there can be at most one solution. If this happened to be a second degree equation, such as a quadratic equation, which we'll talk later in this course, then there can be at most 2 solutions. But in this particular case, since we're dealing with first degrees equations, there will either be one solution, or there could be 0 solutions, and there is one case when there can be an infinite number of solutions, and that is when the equation happens to be an identity. Okay, now in this particular section, or in this particular video, we're going to be focusing on 3 things. One is, given a value for x, determining whether or not it's a solution. Given an equation, finding that value of x that is a solution. And the last thing is, given an equation, first you want to simplify it and then find that value of x which happens to be a solution. This is the first part. And here you're going to be given an equation. You're going to be given a value for x, and the question is that value of x a solution to this equation? Or more specifically, does this value of x make this statement true? Or does that value of x make this statement false? All right, well, how are we going to figure that out? Well, I have a great idea. How about if we take -7, substitute that in for x, and see what we get? Okay, so let's go ahead and do that. I'm going to replace x with -7. All right, and that is our statement. Okay, now, do you guys know what -7 plus 5 is? I bet you do. That's going to be -2. So once I simplify this part right here, I have -2 is equal to -2, which is a true statement. As a consequence, this is a solution. Is a solution. Yay for us. Okay, so that's pretty much what you're going to do for the first portion of your homework. First portion of your homework, you're basically going to replace x with whatever number they give you and see if the statement happens to be true. Okay, well here's the second part. Here we want to see if negative 1.1 is the solution to 1.4 plus z equals 0.5. And what we're going to do, well, we're going to take the negative 1.1, put it into z, and see what we get. And that will be 1.4 plus negative 1.1 is equal to 0.5. All right, that's going to be 1.4, and then if we simplify this, plus negative 1.1 is just like negative 1.1 is equal to 0.5. And what is 1.4 minus 1.1? Well, that is going to be 0.3. If you can't see that, that's why you got to make calculators. Knock it out in the calculator, see what you get. And that's what you're going to have. You're going to have 0.3 is equal to 0.5. Now, is that a true statement? No, there is no way that can be true. This is a false statement. It is a mathematical statement. It happens to be false. We could use a few other words, but this is an academic setting, so I'm not going to use them. So this is a false statement. This is not a solution. Okay, and then the last part of example 1 is this. Here we have the absolute value z minus 14 is equal to negative 3. And we want to know if negative 10 is a solution to this equation. Now keep in mind that the absolute value z is going to be the positive of whatever z is. What does that mean? Well, the absolute value of negative 10 is going to be equal to 10. That's pretty much what we're going on here. So once again, we're going to take this and we are going to substitute that into z, and this is what we're going to get. We're going to have negative the absolute value of 10 minus 14 is equal to negative 3. All right, what's the absolute value of negative 10? Well, that's just 10. 10 minus 14 is equal to negative 3. Well, what is 10 minus 14? If you simplify these two terms, you will get negative 4 is equal to negative 3, which is not true at all. This, once again, is a false statement, and it's not a solution. So how do you handle these types of problems? Basically, you do the substitution. If it comes out to a solution that makes sense, like what you had up here, well, then it's a solution. If it comes out to something which is basically simply wrong, like what you have here or have here, then it is not a solution. So that's the first collection of problems that you will have in this homework. Okay, here's the next. Okay, before we do the next one, we have to talk about one important property of equality. That is the addition principle of equality. And tomorrow we'll talk about the multiplicative principle of equality. And this is what it pretty much says in a nutshell. Okay, we all know that 4 plus 1 is equal to 5. I think we learned that somewhere at some point in time. Okay? Well, what would happen if I added 2 to both sides of the equation? Well, then I'm going to have 4 plus 1 plus 2, which is equal to 7. And I'm going to have 5 plus 2 is equal to 7. So I still have a true statement. So as long as I do the exact same thing to both sides, the equation still will be a true statement. And that's the primary idea behind the addition principle of equality. Suppose I have two things. We're going to call them algebraic expressions. They can be whatever you want. They can be 4 plus 1. They can be 5. They can be anything. I'm just going to happen to call them A and B. Suppose they're the same. Then that means that if I take a third expression, say C, and I add C to both sides of the equation does not change. It still has the exact same solution. There is still an equality. And we are going to use this to actually solve problems. Okay? But just keep in mind, let me just point this out one more time. Whatever you do to one side of the equation, got to do to the other side of the equation. That's how the addition principle works. Actually, I guess that's also how the multiplicative principle works, which we'll talk about in the next video. Okay, so how do we use this to solve equations of the form x plus b equals c? Well, the goal here is to get x by itself. And how are we going to do that? Well, basically what we need to do is we need to move the b over here. And how would we how would we do that? Hey, maybe with the addition principle of equality. For example, if I add a negative b here, and I add a negative b here, and if I can do the addition vertically, these will cancel, and I have x by itself, and then that will be equal to c minus b. And now I know what x is, and all I did was basically add, or in this case subtract, the exact same thing from both sides of the equation. And that brings about our procedure. The first one is to get the equation to the form of x plus b equals c by combining like terms. Okay, what the heck are like terms? Like terms are terms that have one, same variable. In this case, the only variable is x, or no variable at all. That works too. And the same exponent. For example, the numbers b and c are like terms because remember, x is the variable. X and 2x are like terms. They can combine to 3x. X and x squared are not like terms. They cannot be combined, even though they have the exact same variable. This one has an exponent of 2. This one has an exponent of 1. They cannot be combined. So a like term is a term that has the exact same variable and the exact same exponents. Okay, once you've gotten that to this particular term into this setting, step 2 is to add the opposite of b to both sides of the equation, and then to simplify. And if you do, you will have that x is equal to c minus b. And then there's always a third step. We tend to ignore it. We probably shouldn't, because it's the one step that makes us sure that guarantees us that we are right, and it's always good to have guarantees. You want to check just to make sure that we're correct. How do we do that? Well, we take our take our solution, substitute that back into our original equation, and see if the equality still holds. Okay, now, and that brings us to our first example, and here it is. We want to find the value of y that makes this statement true. Okay, what is our solution? The first thing we need to do is simplify. Well, there's really nothing to do here because we are already of this particular form. The only thing that we could do if we wanted to is just switch the order. Hey, cool, let's go ahead and do that. Y plus 5 is equal to negative 11. All right, cool. Next thing we want to do is isolate y, and we can do that by subtracting 5 from both sides of the equation. And notice how I'm doing that vertically. It's just easier to, I think it's easier from a bookkeeping perspective. And here I will have y, okay, cool. 5 minus 5, well, that's 0. That goes away. That's what we're looking for. And then what do we have on this side? Negative 5 minus 11. I'm sorry, negative 11 minus 5, negative 16. So we have that y is equal to negative 16. Okay? And then finally, we want to check. Well, checking for this is a piece of cake, and it doesn't take much time. I encourage you to do that. Negative 16, which is what y was, plus 5 is equal to negative 11. Boom, we're done. Okay, unfortunately, in this course, you're going to have to deal with fractions. Now, I know many of you can't stand fractions. They were the bane of your existence in school. In secondary school, well, you at least need to deal with them for this course. And if you take 116, yeah, you need to deal with them there then as well. Okay, so here we have a linear equation. And once again, we have to solve for x. The approach is still the same. Number one, we want to simplify. Nothing to simplify. We can just do x minus 2/5 is equal to 3/10. Okay. Step 2 is to isolate. Well, we don't want to isolate y since there is no y. How about we isolate x instead? Okay. Well, to do that, what we want to do is we want to add 2/5 to both sides of the equation, basically canceling this out. Okay, now if we add vertically, these cancel, And we have x is equal to 3/10 plus 2/5. Now, there's a couple of ways that you can deal with this. First thing is you can actually use your calculator to figure these things out. There's absolutely nothing wrong with that, except in a number of cases you'll be expected to provide the answer as a fraction, and it may not be easy to deduce what the fraction is from a calculator. Although some calculators can do that for you, it's really probably in your best interest to be used to dealing with fractions. Okay, so how do we deal with a fraction like this? Remember, you cannot add or subtract fractions unless the denominators are the same. You actually have to have a common denominator. Here we have a denominator of 10, we have a denominator of 5, and it turns out 10 happens to be a multiple of 5. So we can actually form a common denominator by multiplying the second equation by 1, or more importantly, by multiplying the second equation by, this term right here, by 2 over 2. This happens to be what 1 is. Now, when you multiply fractions, multiplying fractions is a piece of cake. Because when you multiply fractions, what you do is you multiply the numerators together to get your new numerator, which in this case would be 4. And you multiply your denominators together, which will give you your new denominator, which in this case would be 10. Now we have a common denominator. And how does it work when you have common denominators? Well, your answer is going to have the exact same denominator, 10. And your resultant numerator is going to be the sum of the two numerators, namely 7. And that would be your solution. So here we would have x is equal to 7/10. Now to check it, how would that work? Well, once again, we're going to substitute x 7/10 in for x and see what happens. 7/10 minus 2/5. Well, that's not a 5, that's a 3. There's a 5. Well, once again, we can't really subtract this because I have a 5 and I have a denominator of 5 here and a denominator of 10 there. Once again, since 10 is a multiple of 5, I can multiply this side by 1, or 2 over 2, which by the way is 1. And if I do, I will have, well, let me bring the 7/10 down here. I will have, no, not equals, minus, there we go. Remember that the new numerator is going to be the product of the two numerators, so 2 times 2 is 4. And the new denominator is going to be the product of the two denominators, 5 times 2, which is 10. And then the result is going to have a denominator of 10. That's why we wanted our constant denominator. And the numerator is going to be 7 minus 4, or 3, which is what we were looking for. And this right here is our last example. This is where you all should cheer. Okay, so here we have the equation 3x minus 2x plus 2.5 is equal to 3 plus 2 plus 0.8. Now remember, we have a three-step procedure. The first step is to simplify. To simplify, we have to combine like terms. And like terms are those terms that have the exact same variable and the exact same exponent or power. For example, these two terms have no variable. They are like terms. They can be combined. These two terms have a z raised to the first power. These two terms can be combined. These are like terms and these are like terms. So when you simplify, we will have when we simplify, we combine these like terms. And combining these, we have 3z minus 2z, which conveniently happens to be equal to z. Plus 2.5, there's no like term associated with that. And the other thing is, all like terms are on the same side of the equality, so I really can't combine these with those just yet. All right, and then over here we have like terms 3.2 plus 0.8. They can be combined to 4. All right, step 2 is to isolate x. Now I can do that by subtracting 2.5 from both sides of the equation. Okay. Now, once again, these are like terms. They can be combined, and they can get combined to 0, which is what we're looking for. And then also, these are like terms, and those can be combined to, I hope, 1.5. Either that or my math is really screwed up. No, I'm pretty sure it's 1.5. And that is our solution. Are we sure about that? Well, we can check just to make sure. And if we did, and how are we going to do that? Well, we will substitute 1.5 in for z here and here. And that would give me 3 times 1.5, which by the way is 4.5, minus 2 times 1.5, which by the way will give me 3, plus 2.5, and that's going to be equal to 4. Well, 4 minus 3 is 1.5, plus 2.5 is equal to 4, and yes, this combines to 4. We have 4 is equal to 4. That's a true statement. We are good to go. And that covers everything relative to this particular subsection of 2.3. If you have any questions, please feel free to contact me. And this is Bob Oil, signing off.